All right, so covalent compounds then are compounds that share electrons. So instead of having an atom that takes an electron from another atom or an atom that gives up an electron to another atom, what we have is a sharing of electrons. And so the bonding is a little bit different. And so we can form a little bit different compounds from these covalent compounds. So we have two nonmetals that are forming these covalent compounds. If you remember on your periodic table, you have this little stair-step line that divides the metals over here from the nonmetals over here. So in this section right here, we don't really have very many. There's not very many elements over here that bond in a covalent fashion. Now also remember that hydrogen is a nonmetal. It's our little exception over here by itself, doing its own thing. But hydrogen is considered a nonmetal, so it does fit in with this section as well. So we do have hydrogen as a part of our nonmetals. Okay, so these elements over here and hydrogen form our covalent compounds. These are also referred to as molecules. So when you say molecule, you are talking about a covalent compound. So for example, one that is very common that you're probably familiar with is CO2. All right, CO2 is carbon and oxygen. Carbon is here on this side of our stair-step line, and oxygen is here on this side of our stair-step line. So these are both nonmetals, so they're going to form the molecule of carbon dioxide. Now, how do we name this? What we're looking at is prefixes. Now, in order to actually name this, we're going to look at the number of atoms in our compound and give it a prefix. So we have carbon, and we have one carbon atom. The prefix for one is mono. So actually what we have is we have mono carbon, and we have two oxygen. The prefix for two is di. So we have dioxide. Now we do still change the ending, just like we did in our ionic compounds. We are going to change the ending to IDE. So we have monocarbon dioxide. Now, of course, we can't keep it that simple because we just can't. If we have mono as our first prefix, we typically don't write it. So by convention, we would call this carbon dioxide instead of monocarbon dioxide. Now, if we have CO, all right, this is another very common compound that you're probably familiar with. What we have is we have one carbon at the beginning, so we're just going to call it carbon. And we have one oxygen. So we're going to call it monoxide. Okay, so we're going to take this oxygen, change the ending to IDE, and put the mono prefix in front of it. Now this one we do put the mono. So you can see how these two things are different. Covalent compounds can form all different kinds of compounds like this. So we have carbon bonding with two oxygens, or we can have carbon bonding with one oxygen. And so to distinguish that, we give it the prefixes in front of that oxygen. So what if we have PBr3? Well, if we look on our periodic table, P is phosphorus. There is only one, so we would use the prefix mono, but it's the first one. So we're going to put phosphorus. The second one we have Br, which is bromine. So we're going to have bromide. We're going to change that ending to IDE. And we have three of them. So we are going to have tribromide. So this compound we would call phosphorus tribromide. Now what if we have CH4? Well, we have carbon, and we have one of them. Keep using carbon here. We've got carbon. We have four hydrogens. So the prefix for four is going to be tetra. Hydrogen, we're going to change to hydride. So we have carbon tetrahydride. Anytime that we have two nonmetals, we're going to use these prefixes. Okay, so these are things that you will have to know. Okay, let's just write that. So mono is one. Di is 2. Tri is 3. Think tricycle. Tetra, if you've ever played Tetris, how many little blocks fall down? 4. The pentagon has 5 sides. A hexnut has 6 sides. If you're a heptathlete, you do 7 events. If you're an octopus, you have 8 legs. Nona is 9. If you're a decade old, you're 10. Okay, so these are the prefixes for those. Now, what if we want to go the other way? What if we are sitting here and we have nitrogen trichloride? Okay, what if we're reading through our lab and we find that we see, so what if we're reading through and we find nitrogen trichloride? Okay, the clue here, there's a prefix in there. That tells us that we don't have to do charges. All we have to do is look at the prefixes. So what we have is we have nitrogen and we have chlorine. Since there is no prefix in front of the first nitrogen, it means there's 1. Since tri is the prefix for the chlorine, it means that there's 3. So in this case, whenever you see a prefix, what we will have is the prefix is just writing the numbers. We don't have to worry about charges. Because when you go, if you were to go and look at this, nitrogen is right here with a 3 negative charge. Chlorine is right here with a 1 negative charge. There's no way to balance that. And the reason that is because those electrons are not given up or taken away. Okay. The only time we use these charges is when these nonmetals are bonded with a metal. Okay, that's the only time that happens. When they're bonded with other nonmetals, that doesn't happen. It's a totally different type of bond. And so all we have to do is write those numbers. So what if we have dinitrogen, I can't think of any names here. Oh, dinitrogen trioxide. Let's make up a number here. All right, so when we're going along, we see dinitrogen trioxide. Di means 2, so we have nitrogen, 2. We have trioxide, so we have O, 3. What about dihydrogen monoxide? Okay. Again, we see prefixes. So as we're going along, there's some prefixes there. We have hydrogen, which is 2. And we have oxygen, which is 1. So we have H2O. So a lot of these are going to have very common names. This is water. Okay. If you have nitrogen trihydride, we have N, H3. This is ammonia. So a lot of times you'll see some common names for a lot of your covalent compounds, for a lot of your molecules. But the technical name has those prefixes in them.